Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the Db2Night show, and I've got a very special guest with me again today. Michael Tiefenbacher is back with us. How are you doing today, Michael?
I'm fine. Thanks, Martin, and thanks for having me on the show.
It's always great to have you on the show, Michael. You're welcome back just about any time. That's how we do it here at the Db2Night show. So let me get the housekeeping out of the way and a few announcements, and then we'll pass control over to you because you are the main guest, not me. And here's our Get Involved page as always. Our Twitter hashtag is hashtag Db2Night. Replays are on YouTube. Occasionally we get some interest in some things posted on the LinkedIn group. And there's our disclaimers, copyright and recording information. We will be recording the show. And Michael, if you could please send me your slide deck, we will put that as part of the replay blog.
Sure.
And that would be just great. And people always often like to look at the slides as they follow along. And so there are all sorts of ways to participate in the Db2Night show. And getting through our quick announcements of upcoming shows. Next month for DB2LUW is DB2 Click to Containerize. So if you're interested in DB2 in containers and DB2 on the cloud, we have Tanmay Sinha and Vinayak Agrawal of IBM. They'll be here next month. In April, I expect I'll be lining up another consultant to speak. And on the Z side, we have Cheryl Larson in 2 weeks. And at the end of March, we have Dave Belke of Pragmatic Solutions, or Dave Belke Incorporated. I'm not sure which he's running under. I did mean to fill that in, but there I am right on top of things again. The show is not a show unless I have a couple of typos. I've learned this. And again, our primary and founding sponsor of the Db2Night show is DBI Software, and we thank them for the use of the platform, or as we like to, or the virtual hall, if you want to call it that. And if you're interested in DB2LUW performance, you might want to watch their demo. It's available at the link there. It's available off the DBI Software homepage. And we'll have a brief commercial later on of a feature of the DBI Performance Suite as the show goes on. Our winner is Jim Corsa of DXC Technology. And I looked up what DXC Technology does. There used to be HP, EDS, and a whole bunch of other things that got rolled into DXC. And it was interesting to find that out. I did some work with in Rüsselsheim with EDS many, many years ago. It was good people to work with. So, Jim, congratulations on being an Amazon gift certificate winner. And again, thanks for our sponsors, which is DBI Software and yours truly, Martin Hubel Consulting. And I think next to I've got my joke for the day, which is something with all this COVID stuff going on, I came up with this picture. And well, that's not a good sign, because it's not a good sign, is it? This is the type of things we've suffered through for the last year. And if we're lucky, by the end of the year, we won't have to be worrying so much. I'm not sure about the rest of this year. All right, let's get our polls out of the way. We've only got 3 polls to start with today. The first one is our standard poll that we always ask people is, what versions of DB2LUW are you currently running? And I've kind of updated this a little bit. You can select more than one just to see what people are on. 11.5.5 is just announced. And we've got a good bit of the audience voting. Thanks for voting quickly. It allows us to move on quicker. We'll close that and share the results. And we have most people on 11.1 or 11.5, some people on the newest, and a few people with some of the old stuff lying around. It's typical. The next is our questions relating to the show today. Have you ever used recursive SQL? And some people have tried to use it, too complicated, haven't used it so far. And You know, this is probably a good time for me to tell my little recursive story. I worked on a group pension system back in, I took a break from being a system programmer, and before I got into being a DBA, I worked on a group pension system, and we had a whole bunch of investments. And the easiest way to display investments, because you have mutual funds that can invest in other mutual funds, which can invest in other mutual funds, etc., was to come up with a recursive algorithm to do this. And at the time, I was using a programming language that supported recursion on an IBM mainframe. And so I came up with a nice 20-line routine that would do the explosion of the funds and show the complete holdings. At the time, I had a system architect that didn't understand recursion. So he said, no, you've got to write it all out. And he made me write out the same 20 lines of code, he said, 7 times in my program. So he turned something that was simple and elegant of 20 lines into something that was about 150 lines of code. I was not happy, but these are things. And Michael, what language do you think I was writing in if I could support recursion?
Well,
PL1.
PL1, okay.
That shows you just how old I am. And it was really fun at the time. And there we are. Here's our results of recursive SQLs. People are using it a little bit, and it looks like some people know a bit about it, but you're not using it. So they've come to the right place today. And our last question on this, as a DBA, I think SQL is for programmers only, and getting along to how much more that you do with SQL as a DBA. And as we might expect with this particular topic, the people that are here want to learn more. So what we're finding is our audience is voting towards learning more about this topic. We've got
oh, great.
So you've come to the right place, and I've seen this presentation before, and that's why I asked Michael to do it. And by the way, there's enough stuff here that I didn't think it would hurt me to see a little more of it. So that's another reason why we are why we have this topic today. So with that, let me put that back in place. We have our final question at the end of the session, which is on, did you learn something today? And we'll ask that at the end. So at this point, let me turn control over to you, Michael. I will remain around. I will mute myself as to not disturb anybody. And but if there's a question that comes through, I'll make sure to break in and give the pass the question on to you.
Okay, wonderful, Martin. Thank you very much. So let's start with some iterations of a recursion. And my agenda for today is starting with some introduction in the motivation section. We'll talk shortly about common table expressions, which is a very helpful construct for SQL and especially for recursion. And then we step into the recursion part with a simple example. We will look at the structure, at more advanced examples, and I will give you a couple of options to debug your recursive SQL statement if it won't work at the first shot. And in the end, I have a couple of links and further information in order to dig into it a little more, if you like. So, first of all, I have to thank Henrik Löser, who has created the presentation with me. The other day at the German user group, DDAC, which we run, we were both at that user group, and people started discussing about recursive SQL and complexity and stuff like that. So both Henrik and I thought we should do a presentation about that, and we could also hand it into IDOC. And so the next sessions of the German user group, Henrik presented and I did a presentation, and we found out that it's maybe not a good idea if we both hand it in for IDOC. So we thought, well, let's throw it together. Let's do it a combined session. And this presentation is a result of that. And you can see this nice picture here, which I stole from Henrik's blog. He's also listed at the end in the appendix. He has a couple of blog entries about recursions there as well. So why recursion? Well, it is a great problem-solving strategy. And at some point, it is maybe the only SQL strategy that will solve your problem. It might look different or complicated at first, but I hope I will show you during my session today that there are easy ways to get into it. And with a little bit of practice, you may be able to create your own recursive statement. And a couple of people have already done so, as I found out in the in Martin's questions and answers. The interesting part is that it is recursive. Recursion is a function which references itself in its definition. We will have a look into this. Why do we do this? Well, to loop is human, but to recurse is divine. So follow me on the next slides. To the next slides, what are the use cases? Well, test data generation. It's already mentioned in the SQL cookbook from Game Böchel and others. Whenever you want to step through hierarchies and you don't know the depth, to do root calculation, which is one of my examples today as well. Bill of materials is another very famous example for using recursive SQL statements and recursion in general. Even mathematical calculations could use it for calculating faculty and other things. And in the end, if you stick with me here in this show, I will show you how you could solve a Sudoku with SQL statements and recursion. So this will be fun. This is the fun part at the end of the show, I guess. And it's a little bit complicated, but it is really cool. So whenever you don't know the number of joins, if I have a 3-table join, well, to just do the joins. But if you don't know if it's a 2, 3, 4, or n step in order to get to your result, you're really running into a case where recursion could help you. And one way to get to recursion, you have to know common table expressions. I really love common table expressions, not only for recursion. They are a way to structure your SQL statement. They make a SQL statement more readable, easier to understand, and you could also use it to structure and to reuse parts of that statement at a later point in this SQL statement. So it's kind of a temporary table, but it's only temporarily for the one single SQL statement. And you start with a with clause and you give the common table expression a name. You may have a column list, the keyword as, and in brackets a full select. So you can do a select with that. And you can have multiple CTEs in a single statement. You just have to do the comma separation and give every common table expression a name. And the with clause is just needed at the very beginning of your statement. So let's look onto a simple example. The first one is in the upper left corner with temp date. So I got a date. This seems to be a pretty stupid SQL statement, just selecting a date from IBM System 1. But this is the base for the next step for the recursive part of it. And basically, this is the statement here. And it is creating a separate table called temp, and you can then select star from temp or whatever you need from that. And if you want to do multiple common table expressions, have the with clause at the beginning, just comma separate it, give it a second name, meaningful name. And I like meaningful names, so this T1, T2 is just in order to compact it a little bit, and then you can do whatever you like, join it or use it in subselects or whatever. So common table expression come really in handy because you can really structure your SQL statements very well. So with this statement, this will only return one date, right? Just the 29th of June. And now let's extend it to a recursive query. By doing this, we have exactly the same statement, but we add a union all. So this is the first part is identical to what you just saw. We add a union all and we add another SQL statement. And in this statement, and this may be the complicated part at first, we select from the common table expression again. So within the common table expression, because it ends at the bracket down there, we reference it again. So this is what you have to think about or to accept in order to create our recursive SQL statements. What do we do here? Well, date plus 1 day. Whatever is returned by the date column, which is this date here, add a day, add another day. And then we have a break, a stop condition. I say, well, I don't want to go on if the date, I want to go on as long as the date is less than the 19th of October 2018. And on the right, you can see the result from that statement. And it doesn't matter what date you put in here, you will always get one row for each date. So this is a very simple example to generate data. This could, of course, be used by extending it a little bit to populate a time dimension for your data warehouse, for example. So it really has its use cases. So in order to help you to get along with that, I came up with some color coding. And this is what you really need. These are all the components you need to create a common table expression that is a recursive common table expression, and overall it's recursive SQL query. So let's start with the width, and the common table expression is just give it a name. We do a select, we select the first row, whatever you need to get started. This is the simple part of it. Get the first row, select the first row, and in order to help us in the end, we introduce a counter here. So, oh, sorry for that. We introduce a counter and we set the counter to 1 or 0 or whatever. So we initialize a counter, the counter column, and we do a union all, and then we do the second query, which selects the second row, basically, at first. And we also, and this query selects whatever, but it selects also from this CTE recursion, which is my common table expression. This is the heart of recursion. This is the self-referencing stuff we talked about. And then we use the counter we introduced in the first statement. We use it, the counter to provide a stop condition in order not to loop endlessly. DB2 doesn't like it if endless loops. It could cause memory problems, of course, and stuff. And in the end, the bracket closes the common table expression, and you have just a regular SQL statement selecting from the common table expression. So in this example, it's a very simple query. It could be any query you like. So these are all the components we need for a recursive statement. For a simple or a complicated one, it doesn't matter. If you follow these lines, you will succeed. So let's look at some more examples. But first of all, you could run into problems. And first of all, there's a distinct is not allowed. So in these SQL statements, don't use any distincts, not in the common table expression of the recursion. And while usually in a common table expression, you could avoid listing all the columns if all the columns in your select has a name or have a name, like the one as counter and stuff. So they usually have a name. If you do calculations, just name it with the as. But within, this is a special situation. Because it's a recursive common table expression, you really have to list the column names. There's no way around it. And the third thing, and I think this is quite interesting.
Sorry, Michael.
Yes?
There's a couple of questions. from a couple of people mentioning how is that counter updated is what they're asking from the last slide.
Yes, the counter is updated. This is not yet here. It needs to be here in this select. I will show you right in the next step of the next example.
Perfect.
I will point it out.
Yeah, thanks.
Yeah, good, but it's a good point. It's absolutely right. The interesting part is that for recursive CTEs, you're not allowed, still not allowed to use the new join syntax with the inner join and the on clause or the outer join or whatever you need. It is still using here, you're stick to the old comma separated join like we had in one of the examples earlier, like this one. This join and of course a where condition where you put in your join condition. And this is a limitation. Actually, this is a limitation in DB2 LUW, but not in DB2 for COS. They know how to do it. So I have no idea why this hasn't made it to DB2, but I still hope we will get it in one of the next fixes or versions. This is, as far as I know, the only point where you are forced to use the old join syntax, actually. Okay, so let's jump into another example. You all need the DB2 sample database, I guess. And this is the departments table. And the departments table, each department has a name, has a number, and has an administration department. And this is kind of a parent-child table. And so let's walk through that, because with recursion, you can step through hierarchies. And this is what we are going to do in our next recursion example. So let's start again. We do the common table expression. We list all the column names because it's needed. We introduce a counter. We started at 0 at that point. And we define our first row. And the first row is, we will start with department D21. And we will see where we will end. We do the union all. We do the select the next level. And look at that. This is the point, the level +1 as level. This is where we increase the counter. And this is where we provide a stop condition. Don't do it, or just do it until level 4. So from 0 to 4, 5 times. So in order to ease the readability a little bit, let's do the color coding again. So you see we get all the colors needed. We introduced the counter, we increased the counter, and we used the counter as a stop condition. Actually, in here, we had 2 stop conditions because depth number and administration department. Why that? Because if you jump back, if you look at that, this is you have to know your data, of course, because in the main department A00, this is administrated by itself A00. In many situations, you find a null or empty value here, but in that case of the DB2 sample database, this department is administrated by itself. So if I come to this department, I don't want to go on because I'm getting nowhere else. And this is why it may make sense to provide an additional stop condition if you reach your target level earlier than the 5 after 5 iterations of the recursion. Okay, so again, I hope the color coding helps a little bit to understand it. And this is where you increase your counter, introduce it, increase it, and use it. So hierarchies can be used really everywhere. And we have done a business scenario with the department, but now we are back to DB2, to the DBA examples. And because in the system catalog, there are lots of options where recursion could help you as well. And for example, imagine a view is created on a view is created on a view and a view in a table. Well, you don't know how many levels of views are created above your table, do you? So let's check it out. Let's try a top-down approach. So we have a object on a certain level. And this is what I select within my first SQL statement. Level 0, select this, the one view you are interested in. And then you do the union all, joining the temp table with the tab department, the table dependency table. And this is the join condition because this is the base table, and look at the table name and so on and so on and so on, and limit it to 9 iterations, to 9 levels of recursion, and select from it. So with this query, you will get to the base table. But you might be interested in the other way around. So maybe your scenario is something different. Your scenario is you have a base table and you wanted to know what views are built on top of it. So you can just turn it around from a top-down approach to a bottom-up approach. So the only thing that changes here is the SQL statement to select the first row is a little bit different because you're looking for a base table called employee, and the change condition, the join condition changed. Look at that. It's still the same, but this TD is from the system catalog, and T is from the temp table, from my common table expression, and in the top down, it's actually the other way around. So this makes a difference, and with that you can go top down or bottom up, and with this it ends up in a kind of template. So I provided a template. What do you need in order to create a recursive SQL statement? You need the common table expression, a column list. Don't forget the join column. Don't forget a level because it's helpful. It is not needed as a result actually, but it is really, really helpful. So I highly recommend using it. From a base table and start condition, remember the first select statement selects your starting row. Do the union all. Actually, it has to be a union all. A union will not work in that case. Union all is more efficient and is absolutely needed here. And then you do your second SQL statement. Again, the same column list as used up here. Don't forget the join column. Don't forget the level and increase the level by 1 as level. From the common table expression, well, this is already a fixed thing. You need that. And the base table again, join that. Remember, using the old join syntax with the comma. In the where, use the join condition. And make sure you limit your loops. Stop the recursion at some point. And then do whatever SQL statement you need. So this is already, I think, a good template in order to start with your first recursive query if you haven't done one before. I looked, by preparing my slides, I looked through a lot of recursion presentations I could find out in the internet, on the IDOC site and others. And they were pretty interesting. But the one thing I could not find is any information how to debug it. If something does not work out when you create it, how could I debug it? So I thought, well, maybe I could come up with some ideas. And this is what I got, some very simple ideas for first debugging scenarios. There are 3 parts of it. The first part is, well, check out the first SQL statement because it could run by its own. Check out the first and the second SQL statement. I will show you how to do this by just commenting union all, and it's presented in the next slide. And please use a simple SQL statement to select the common table expression because your problem could be also in the SQL statement selecting that. So let's have a look at that. That's one of the examples we just discussed. And let's do some problem determination, some debugging here. So what I would suggest is run this first. Is this really providing your first level? Is this really providing your starting row? So this could be just marked in your tool, just mark it and run it. This is simple as it gets. On the second level, we want to run this statement as a common table expression and the second statement. So this would be level 2. How could I do this? Just mark that and add 3 characters. End the bracket here, end bracket here, and comment out the union all. This will now result in the level 1 being a common table expression, and this being the select statement of the common table expression. So this is really a good start to select the first 2 rows, basically. And the third thing is, of course, do a simple select statement from the common table expression down there. So 3 simple steps, but they will help you to dig down to the problem and to debug your SQL statement. Okay, so there's a little time for a commercial break Martin wanted. And after that, stick with me and I will show you an alternative syntax for running SQL statements, recursive SQL statements within DB2. Martin, your turn.
Thanks. I'm just getting a couple of things together here. Got this one video that should be starting soon. There it is. Go. Here it is. I just need to find out to get the sound up. Last time we had trouble with the sound on this. Let's see what I can do. Sound. Oops, here it is. Okay, I will pass control back to you, Michael, and we can carry on. Thanks for watching.
Okay, so let's look into an alternative syntax. We can use the Oracle syntax as well, which is a little bit different for recursive statements. And Oracle uses a connect by syntax. I will show you on the next slide. For some, it may look easier, but you're free to use it. So you can do this. The only thing you have to do as a prerequisite, you have to set the registry variable, the DB2 compatibility vector, to 08. There's no need to create a new database, but there's a need to restart your instance of it after you've done so. And the interesting thing I found out when I created that, you know, it's always a good learning process creating presentations for some events like a night show or a conference. You learn a lot by doing this. And what I learned at that point is that it is not only a different syntax, it is also processed differently in an Oracle style, because the Oracle style of processing recursive SQL statements, if you imagine a tree-like structure for that, it goes depth first, while DB2 usually goes width first. So it's a different internal processing. I thought this is pretty interesting, and it also has a limitation of 64 levels. This limitation is not there if you do it in the native style, which I showed you before. But it's usable, and we come back to that our really first simple example by accelerating dates by 1 day and creating a list of days. And this is the same SQL statement by using this connect by Oracle syntax after you have switched to your registry variable, like I showed you on the last slide, and do this date plus level of days. And this is the stop condition again. So it is maybe a little bit simpler, but less to code. You can use it. If you're used to that, you're free to use it. But the one thing I thought, well, if the internal processing is different, how will it show up in an explain? And I compared both, and it is really different. And this is the proof. It's a complete different path for generating it. It is in general quite interesting to look at recursive statements explain outputs, because they have a temp table and the temp table is used here again. So this is the structure of the regular DB2 syntax with the recursive comment table expression. And this is the Oracle style. The estimated cardinality is about the same. The CPU costs is different. But I could of course imagine that at some for some problems, the depth first may be beneficial, and at some problems, the width first may be beneficial. So check it out, do some experiments, and I'm interested what you figure out. But I thought this is pretty interesting stuff, not doing just a syntax, but also a processing, a different processing way of it. Okay, so the next little bit more complicated example is providing a flight route, doing a routing. And I got some data from the internet. There's lots of stuff out there for free. So I downloaded all the airports at that time, all the airline routes, all the airlines, and I imported it into my DB2. And then that was it. So let's check out. I want to fly, let's say, from Frankfurt to Philadelphia, and with a certain number of hops, of intermediate stops. And what options do I have? So this was the business problem, and this is how I solved it. It's a recursive SQL statement, again in the traditional way, and I've put in on the right lower corner the our structure diagram, and you see with the colors, I've got all the colors, I introduced a counter, I increased the counter, and I provided a stop condition. And, well, the SQL statement is a little bit more complicated. But I have extracted the key parts of it in order to show you what I really did and what I really, how I tried to achieve it. I said, well, if I want a route, I will want to go from A to B. I do a concatenation in order to show it, because I have to know where are my stopover points. So I said, well, have the source airport concatenated with this arrow in order to show my direction, where do I go, and have the destination airport, and put this, combine this together into a string. On the other side, I've did some optimizations, I would like to call it. It just makes sense to use airlines that really reach the destination airport at some point. And this is with the exists clause. Say, well, the Philadelphia is my destination airport, and I just want airlines that land at my destination. And in order not to cycle around too much, because of course from Frankfurt you could go to London and to Frankfurt and to London and to Frankfurt before you fly directly to Philadelphia, maybe. And this is not nice, going back and forth all the time. And in order to avoid that, I came up with this solution. So I have the route. So it's part of the route here. This is where I create my route. So my route holds all the airports I have been to already. And it checks if the new destination airport is already part of the route. If it's located in the string, it would be not 0, it would be 1, for example. And I just want airports that are not already part of the route. And once I have landed in Philadelphia, I don't want to go on. I will not use Philadelphia as a source airport. This is not allowed. And I limit, of course, as a break condition, the hops. Okay, so these are the key approaches that have been built into this SQL statement. And this is the result. So there's the last step, of course, on the airline, coded airline, the number of hops, and this is the route. I think this is quite interesting, much more interesting than just the last step. And in order to get it, I concatenated all of my airports and destination and intermediate targets. So this is a huge list, and I can now choose which way do I want to go, which country or airport or city do I want to see on my way to Philadelphia. So quite interesting. So a little bit more tricky, but really I got all the necessary structures that we need, and just do a little bit more of thinking how to avoid loops and stuff like that. Okay, so this was a little bit more complicated. We will go now to a completely other scenario. It's an XML scenario, and this and actually Henrik Löser came up with this. And Henrik is a great presenter at conferences, but he has been working in the Db2 lab before, and he was involved in the XML development when Db2 at that time got support for XML data type and XML query and stuff. And he wanted to challenge Db2. So he thought he needed really large XML documents of different depths and different sizes in order to check out if Db2 can handle those. And this is what he did. He used recursion in order to provide complex and very complex XML documents in order to challenge the Db2 processing engine, and in order to find any errors. So by running this, you get huge XML stuff, and with the number of levels and details you want. So it's again a part of the data generation thing. And it also works out with XML. Okay, so having said that, I want to show you another extreme example, a fun example in my eyes, solving Sudokus. This is something I promised you at the beginning. And you may all know Sudokus, but for the ones who don't know it, it is a puzzle like shown on the right side. And you have to use the numbers 1 to 9 once per row, once per column, and once per square. So each square, just 1 to 9, is allowed a single time. I think this is quite funny. So I never thought of using SQL to solve Sudokus before, but when I came across this, I thought this is pretty interesting. And I digged into this a little bit. So this is not all my own code, but I adopted it to DB2. And I think this is funny and very, very interesting SQL stuff. So for all the ones listening to this show are called advanced admins or advanced SQL programmers, I would encourage you to look into this SQL statement. It's really interesting. And well, I have to tell you a little story. When we presented that, we asked the attendees who thought of doing that, and I didn't expect any hand going up, but of course the SQL specialist of the IBM lab raised his hand. He said, "Yeah, I did this. I tried that once." And he has, of course, used his own strategy, but I thought this is really funny. And this just shows how powerful SQL is. And you can do lots of it and more than you ever thought, I think. This is something I experience in my projects all the time. SQL is a really powerful language, and it's much more powerful than most people think. Okay, so the first challenge is I have to provide this input, this square. And this input is provided by having a dot, a full stop for an empty field, and of course the numbers that are already pre-filled on that. So looking at that means this is a dot, this is a dot 9, 4, dot, dot, and so on, and just read it line by line. And this will provide, this is the input string. Okay, so this is the first thing, and this first is provided in a common table expression, because the challenge is not to get a program solving a Sudoku, but a single SQL statement. So this is my first common table expression, and now I need a second one in order to provide all the possible numbers. And this is a second common table expression. This is just with again a with clause in order to check it out. And to provide the example on the right, it will generate the one as a string and the one as a number, and we'll do this 9 times. So 1 to 9, all the numbers will be provided in 2 different data types, as a character and as a number. Of course, there's an alternative. You could also do a values clause here, like this one. This is an alternative, but remember, guys, this is a recursion presentation, so this is more fancy, and by now you're all able to do this. But this is not the only recursion, of course, because we have to talk how to solve Sudoku now. And these are just the preparation steps. So 2 common table expression, and now let's talk about the heart of solving the Sudoku. And that's it. And it's not too big actually, but it's a little bit complicated, especially in the second part. Select the first dot. Well, let's look for the next number to figure out. And this is really the idea behind that is really a brute force thing. So you just check it out. What is possible? And I think that is pretty interesting, and it's hell fast. So even if it's brute force, it is really powerful and fast. So select it, divide the string, search for the next point, and then try to fill in a number. The number is in the digits part of the common table expressions above. It is the generated thing, so the 1 to 9, and this is just a Cartesian product. So join it to everything, and then check what is valid. And valid is, well, that it is only allowed once per row, once per column, once per square. And the interesting part of it is how this is calculated. Have a look into this. I can't go into all the details, but it's really interesting stuff. It is, I would call this SQL maths, because it is maths, but it obeys SQL rules. So, and this is the important point in order to figure out how this works. And it's especially the maths for the same square is quite interesting. And so this is nice stuff. And if you have some more time and you will get the slides and all, dig into it a little bit, do some experience. I promise this is fun. So running that will give us this result. So we get one large result string. And if you do some formatting, pretty formatting, this is the result you would expect from the input we just saw. And Henrik has some formatting SQL and stuff provided, and this code and also the formatting is available on GitHub and will be shown on the next slides. So even really hard puzzles can be solved like this, and I thought this is pretty funny to solve Sudokus and to show the power of recursive statements. So in order to end that, I've provided some further information. Queries and other materials, as promised, is provided by Henrik. Also, I really highly recommend Henrik's blog. He has a lot of security topics as well, cloud topics, recursion topics, and check it out. This is really worth it. And there have been IDOC sessions, very interesting ones, also from Daniel Luxetich and Alexander Kopacz, Parlez-vous Klingon. Quite nice stuff. You might find additional examples, some other slides, some other ways to look at that. And also for the I-series guys, the Connect By syntax is available. I thought even if you're DB2 or DB2 LUW, it makes a lot of sense looking into the other documentation. And I the migrate recursive SQL stuff on the developer works site. This link still works. I checked it out. There's good data generation examples by the highly recommended SQL Cookbook. And of course, in the Knowledge Center, you will find additional information as well. So that's from my side. Follow me on Twitter. And Martin, are there any more questions?
We didn't have any more questions after the last one. There was some brief discussion, which I answered on SQL versus in ZOS or ZOS versus Oracle versus LUW. And yes, there can be some differences, and that's a science project for each one of our esteemed listeners and members of our audience.
Okay, so
I'm going to take that control, and once again,
I want to thank you for listening, and I hope you've learned something or find some interest in some of the examples, and always remember to iterate is human, to recurse is divine. Thanks very much.
Yes, and I'm looking at the Sudoku things and knowing my wife has a book full of them. And if I walked in and said, I can do that as an SQL function, I'm just wondering how dirty a look I'm going to get if I tell her that. But it would still be kind of fun to do. But with that, let me ask our final polling question here. And that is, of course, did you learn something today? And giving everybody a chance to vote on this. And if anybody said no, they probably had attended your presentation before, because I think it's absolutely great. And with that, and I'm also very pleased that we've got this in our replay library to show people. And, seems one or two people saw it before, but 92 is still a great number. And I thank everybody for voting. And with that, I will move the slides again ahead. And I will cue the music. Thank you again, Michael. Appreciate you doing this. I appreciate you sharing your vast knowledge with the DB2 community at large. It's always great to see you.
Thank you, Martin, for having me. It was a pleasure to be here. And yeah, enjoy the weekend. Everybody and stay safe and healthy.
We've got a holiday here in Canada on Monday. We're calling it Family Day, and we're going to be having a day off to enjoy this extremely cold weather we're having. But take care, and we'll see you again on the next Db2Night show, 2 weeks.
Yeah, wonderful.
Thank you. Bye-bye.
Bye-bye. Bye-bye, everyone.